Welcome back, ladies and gentlemen, to the second part of section 2.6, special functions. With number 1, notice how we have step notation donated by those brackets. Now, when we have that, usually in most tables, we would pick 0, 1, 2, 3, 4. Well, when we have step function notation, we have to have a range from 0 to 1, right? And then we go from 1 to 2, and then we can go 2 to 3, and 3 to 4, and you could go down this list doing the same thing. Well, now when I say 0 to 1, that means I can pick any number 0 to 1, and I'm going to round down back to 0, right? So let's put 0.57 in the brackets, correct? Well, 0.57, we would round down all the way to 0. And now 1 to 2. If you pick 1.5, we would round down to 1. Or 2.2, we would round down to 2. And then let's put 3.9. It's not quite 4. We're looking for the greatest integer less than or equal to that, and it would be 3. So now what does this look like on a graph? Well, 0 to 1 is right here on my x, but it's at the y of 0. So here, now it's going to be a closed point to a open point. And now I'm going to do 1 to 2. I go 1 to 2, and that's at y is 1 or f of x is 1, where my f of x value is 1 or my y would be 1. 2 to 3. So I find here's 2 to 3. How high do I go? I go up 2. So I put a point, and I have a open circle with a bar, or open circle with a bar attaching it. And then 3 to 4. Here's 3 to 4. And where is it on the y? It is at 3. So I move it up. Again, it's a closed circle because it can be that. And then bar, open circle because it's not that. And now this would continue in both directions, and here is where we get our steps because it looks like a staircase. Now with number 2, when you have a 2 attached to your x inside that step function, we want to get it to look like this essentially. So with whatever's attached to it, we want to get it to be 1x. Well, what would I have to multiply this guy to get it to be just a simple x? I would have to take it times 1/2. So whatever you have to take it times, that's what is going to be our intervals for our x. And so here, it would be 0 to 1/2, 1/2 to 1, 1 to 1 and 1/2, and then 1 and 1/2 to 2. So let's try it out. What would happen if you picked 1/4? That's between this guy. You pick 1/4, it becomes 1/2. Well, anything in this value you round down to 0, so it would be 0. 1/2 here, you plug it in. For this x, 1/2 times 2, you'd have to round down because it's 1. This is going to be 1. Then you plug 1 in. It turns out to be 2. You plug anything in this interval, you would find out that it rounds down to be 3. And so let's take a look at graphing this guy. Now it's 0 to 1/2, and it's y at 0. So 0 to 1/2 looks something like that. 1/2 to 1, and we're at y of 1. So let's put a point, open circle. And then 1 to 1/2 at 2, so we put a point, and then open circle. And then 1/2 to 2, we have 1/2 to 2 on my x, point, open circle. Again, notice that we have the steps going in both directions. They are just shorter steps now. Now looking at 3, now we have a 1/2 x. Remember, we want it to look like that. So what do we have to multiply it by? We would have to multiply it by 2. So now our steps are going to go in intervals of 2. So we have 0 to 2, 2 to 4, 4 to 6, and 6 to 8. You can plug anything from 0 to 2 in this x, and you would have to round down to 0. You would plug anything from 2 to 4 in for x, and you would have to round down to 1. Then you go from 4 to 6. Anything in that value would be 2, and anything in this value would be 3. Now let's try to graph something like this. Here we go from 0 to 2. So I put my point at 0 to 2 and go all the way to 2, and that's at y of 0. And now I go from 2 to 4, which is this range right here, and I go up for y is 1, point, open circle. Then 4 to 6 is right here. I go up 2 for that interval, and then 6 to 8 is right here, and I go up to 3. Notice that this would continue in both directions. Let's try one more example with function notation. Now notice how this 2 is outside the step function. So when it's outside the step function, we can just pick our normal intervals. So we're going to go from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Now we have to be careful when we plug things in. So 0 to 1, I'm going to pick, you can pick any point, but I'm going to pick, let's go with 0.5. Now that 0.5 is in the step function notation, or is in the greatest integer function, and now we would round that down to 0, correct? So then it would be 2 times 0, which is 0. Then we would have 2 times 1.5. Again, you can pick any number inside 1 to 2. Now this 1.5 would round down to 1, so 2 times 1 would be 2. And then same situation here, it would be 4, and then 6. Again, now we have to plot these. 0 to 1, right here is at 0. Then we have 1 to 2, which is here, but it's all the way at 2 now. Then we have 2 to 3, which is right here, but it's all the way at 4. And then 3 to 4, and it's all the way at 6. Now let's move on to a word problem. Here we have a psychologist charges a counseling session at a rate of $85 per hour and any fraction thereof. Now we're asked to draw a graph that represents this situation. Well, $85 per hour tells me no matter how long I go, I'm going to get charged $85. So as soon as I step in the door, I'm going to get charged $85 all the way up until that first hour. Now from hour 1 to 2, I'm going to get charged double that, right? So I'm going to get charged $170. And then from 2 to 3, I'm going to get charged 3 times the amount. And it's just going to keep going up and up and up. Now we're going to move on to an absolute value function. When we have an absolute value, how do we represent an absolute value? Remember, it's with those bars, right? It's straight up bars. Now, when we fill in tables for this, we want to put in 0. We want to have 0 in the middle of our absolute value. So I have half of it done for you, where 0 is still 0, 1 is 1, 2 is 2. Now, though, if we put negative 1 in for x, the absolute value of negative 1 is 1. The absolute value of of negative 2 is 2. Absolute value of negative 3 is 3. So if we plot these points, negative 1, up 1, negative 2, up 2, negative 3, up 3. And now what kind of graph are we going to make? We are going to make a graph that looks like a V. So we need, for an absolute value function, we need to have a graph that looks like a V. Again, we need a V. For the absolute value function, we need a V. A V. Now, when we move on to this blue guy, notice how this x is all alone, all by itself in the absolute value. With that being all by itself in the absolute value, It is fine. So then the middle value we would have in our table would be 0. We would plug that 0 in for x. Now, once you have your middle value in your table, you can put negative numbers in and then positive numbers in from that point. So it would be 1, 2, and 3. And then going down, it would be -1, -2, and -3. So now if I put 0 in for that x, it would be 1. If I put 1 in, it would be 2, 3, and 4. Now if I put -1 in, be careful here, ladies and gentlemen, -1 is actually a positive 1, so it would be 2, 3, and 4 here as well. So if we would graph this, we would have 0, 1. We would have 1, 2, 2, 3, 3, 4. We would also have -1, 2. We would have -2, 3, and we'd have -3, 4. We could then connect our dots with a line, and so again we have a graph that looks like a V. Now be careful though with this red guy, because notice how we have x plus 1 in there. We want this whole guy to be what? We want it to be 0. What do we have to put in for x to make this 0? It would be -1. So now we're going to start at -1 and move up and then move down. So we move up to 0, 1, and 2, and then we move down -2, -3, -4. So now if I put -1 in for my x, it would be 0. If I put 0 in, it would be 1, and then 2, 3. Now if I put -2 in for that x, it would be a -1, but the absolute value of -1 is +1, and then it would end up being a +2 and a +3. So now let's graph this. So 0, or it goes -1, 0. So I go -1, down 0, put a point. Then I go 0, 1, 1, 2, 2, 3. Now moving to the other side, it's -2, up 1, -3, up 2, -4, up 3. Now we connect those dots with a line, and notice what the 1 inside the absolute value does to my graph compared to outside. The 1 moves it over, and the 1 outside moves it up. And then finally, I just want to reiterate, step functions, we want to get that x to 1. Remember, we want to get that step function to look like just x. And then absolute values, we want to have 0 in the middle of the table. So here, and I'm sorry, this should be an absolute value. So here, the middle value in our table would be 0, but x plus 2 in an absolute value, our middle value in the table would be -2. And that's it for section 2.6, special functions. Good day.